Okay, we're trying to finish the material for test 1. We have test 1 a week from today. I will move 2.5 to the second test. So the last section that I was going to present before test 1, I think we're going to move it to test 2. Okay? So today we're going to finish 2.2, and 2.3 and 2.4 are together. Just a review of lines. That's all it is. So, but I would like to go back to 2.2 because we did not finish. There are a few loose ends in 2.2. But first, I'd like to take your questions. Any questions for me before we do that? Yes, please. I'm ready. I just dictate.
X to the 4 plus y to the 7.
Y to the 7 equals? Okay, what are we trying to do? To see if it's a function of x? Okay, we have to do what? Every time we're asked, we're given an equation, or we're asked to identify whether it's a function or not. What do we do all the time? Last time, I know we just reviewed it. We have to? But the idea, the whole thing, how we do it in a second, but what is the idea? What are we trying to do? Exactly, solve for y. Solve for y. Okay, so y to the 7th equals negative x to the 4th plus 9. Now what do we do? We have to solve for y. What is the last step? Yes, take the, it's not the square root. The square root will not work. It will not eliminate the power 7. What will eliminate power 7? The 7th root. And as we know, every odd index has only one solution. So y equals the 7th root of negative x to the 4th plus 9. For each x, you will only find one y. So the answer is yes. It is a function because to each x, we only find one y. Anything else? Is there anything else you worked on? Other questions for me? Other questions? Anything else you had difficulties with? Anything? Anything else? Okay, then let's go back to section 2.2. I would like to talk about symmetry. That's what we did not get the chance to look at. And then I would like to go through a word problem to see where is this applied and why. And talk about max-min of functions. Okay, so our first step is symmetry. Are all functions symmetric? Well, the answer is no. Okay, I'm just checking whether I started the video. I think I did. Yes, I did. Okay, so are all functions symmetric? No, they're not. But if a function is symmetric, there are two possibilities. The function to be even. This has nothing to do with even numbers. It's just the name of the function if it is symmetric. If it is symmetric, if it is symmetric with respect to WRT, I'm lazy, with respect to the y-axis. If a function is symmetric, its graph, of course, is symmetric with respect to the y-axis, that function is called even. There is also a function called odd. If it is symmetric with respect to the origin. If a function is symmetric with respect to the origin, we call it odd. It has nothing to do with odd numbers. It's just the name of the function. When we say the function is odd, we know its graph is symmetric with respect to the origin. When we say a function is it's even, we say, in other words, it's symmetric with respect to the y-axis. Okay, now let's look at two graphs. Here is one. And here's the other. We will review these graphs again past 2, that's 5, that I will leave for the next test. Okay, so in this particular case, this function, this graph is symmetric with respect to the y-axis, because if I fold the paper, those two parts of the graph will overlap. So this is symmetric with respect to the y-axis, which means the function is even. We'll get to the second one in a minute. I'm going to do this. I'm going to draw a horizontal line crossing the graph in 2 points. And I'm going to say that this, of course, this is a function, f of x. This is another function. I'm going to say that this is x. And I would like you to give me the y coordinate here. In other words, this is point A. Point A has coordinates x, comma, and I'd like you to tell me what is the y coordinate of A. If it's x coordinate, it's x. What could this be? Correct. Awesome. But in another way, we say it again. Very good. F of x. Now, on the other side, what do you think this will be? Awesome. And now, forget about the right-hand side. I would like you to determine the y value or the y coordinate of this point. So if this is negative x, I would like you to determine the y coordinate without completely disregarding the other side. That's why I covered it. You only have this, and I'm asking you what is the y value of that point. What will you say? F of negative x, of course. There is no other way. So now I would like you to tell me the relationship between, for this function, negative f of negative x and f of x. Look at the graph carefully and say that these two absolutely the same. Same and identical. Therefore, the function is even. Every time this happens, the function will be symmetric with respect to the y-axis or even. Here's an example. F of x equals negative 3x to the 4th plus 2x squared. Do you think this function is even? Let's say we don't know. Even if you can tell, that's fine. But let's say we don't know. I decided moving forward, starting from today, that if I see your cell phone, I deduct 1 point on your table, or you touch it during the class. I deduct 1 point from the next test grade. Every time I see you touching your phone, or it's on the table, or it's under the table, 1 point off.
What if we use it for a calculator?
I'll give you my calculator. And I see from here very well in the back. So please put it away right now. Thank you. Away meaning in your backpack, on the floor, or anywhere else, not on the table. Thank you. Okay, so in any event, we're asked to show that this function is even. Or we're asked, is it even? So the question is, what do I have to do? Here's what I have to do. I need to determine f of negative x. So let's find f of negative x. If it happens that there is no change from the function, then I'll say it's even. So, can anyone tell us how to write this? We know how to evaluate functions. So, what do we do? What do I have to write? Very good. You have to say parentheses, otherwise it's wrong. Yes? What do I put in here? Awesome. I have to say close parenthesis. Very good. Excellent. No. No. Yes. 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 Awesome. Excellent. Great job. So now I would like you to determine this. Anyone? Can anyone tell us, well, how much is negative x to the second power? Very good. So it's x squared. Can anyone give us negative x to the fourth power? What is it? Excellent. So then can anyone put everything together and tell us what this equals to? So now I'm asking myself, does this equal the function itself? Does it? Are they identical? Awesome. So we say the function is even. Let's look at the other option now. This time I'm going to do something else. Any questions? Is this okay, everyone? Okay. So this time I'm going to do something else. I'm going to connect 2 points on this graph with a line segment going through the origin. And then I'm going to say that this is x, and I would like you to tell me what is this value. Very good. Now, can anyone give us what this you think it is? This value here. Excellent. So please do not look at whatever we have on the other side, and please give us the y-coordinate of this value of x. Do not look at anything else. Just look at negative x and tell me what to write here. Excellent. And now, for this situation, I would like you to give me the relationship between f of negative x and f of x. So let me give you a hint. If this is 15, how much will this be? Correct. If this is 3, how much will this be? Good. So then what will be the relationship between these two? Say it again. They're not equal. I mean, 3 and negative 3 cannot equal. 10 and negative 10 cannot be the same. So they can be opposites, right? That's all it means. So this value is the same with that value, but with minus in front. Is that clear? So this is negative 5, let's say, and this is 5, but with minus in front, they will be equal. They're opposite of each other. Okay, so let's look at an example. Let's say f of x equals negative 3x cubed minus x. Here is the same question. Is this function symmetric?
No.
So we have to, I have to just explain that there is no function that is even and odd at the same time except y equals 0. But who cares about y equals 0? Y equals 0 is the only one that is symmetric with respect to the y-axis and with respect to the origin. But who cares about y equals 0? No one. So if a function is even, you don't have to check that it's odd. If a function is odd, you don't have to check that it's even. It cannot be both at the same time. Okay, so here we're asked, is this function symmetric? So what do we have to calculate? Obviously, no matter what the answer is, what do we have to calculate? Every time I'm asked, is this function symmetric? What do I have to calculate? Of course, f of negative x. So please tell me what to write. Good. Awesome. Awesome. Perfect. Close. Very good. Minus. Excellent. Good. So now can anyone tell us what this is? Negative x to the third power. How much is negative 3 times negative x to the third power?
3x.
Very good. 3x to the third power. How much is negative 1 times negative x? Sign?
Plus x.
Plus x. Good. So now I have 3 questions that I asked myself. Here's the first question. Here's the second. And here's the third. Is this the same thing with f of x? Because if you say yes, then the function is even. Is this the same thing with the opposite of f of x? If you say yes, the function is odd. Or none of the above. The answer is yes to only one of these 3. and 2 no's and 1 yes. So this was the original function, and plugging in negative x, we got this. If they are the same, then I say check here. Are they the same? No, so the function is definitely not even. Now I'm here, and I have to check whether this function equals the opposite of this function. No problem, I can multiply both sides here by -1. I multiply on this side, I multiply on this side, and now I'm asking myself, is this function the same thing with this function? This function being this. Are they the same? So then I will have to say yes, the function is odd, because f of -x is the opposite of f of x. Any questions? Any questions on symmetry? Okay. Max, min, and then we look at problems. Okay, so I'm going to present 2 graphs. Here's one. This is the graph of f of x. And let's say that this is graph of g of x. Are these functions, by the way? By the vertical line test, they are both functions. I hope you agree that the function is increasing between -infinity and -5. It is increasing between 2 and infinity. Would you agree?
Yes.
And then the function is decreasing definitely between -5 and 2. Okay, perfect. At this point, because the function exists on both sides, and I can show you the open interval where all these functions' values are smaller than this one, is called a relative or local max. We use both definitions. I mean, both names. Why? I don't have an answer if you ask me that. I have no idea why we use both. In certain books, you'll find it as a relative max, and others as a local max. It doesn't matter. What do you think this will be? It's local min, because the function exists on both sides, and I can show you the open interval. Now, looking at this, obviously, I'm going to say that this point is also a local max. Do you agree? Because I can show the open interval, left and right. Now, the question here is this a local minimum? No, it's not a local minimum, because I cannot show you the open interval on this side. The function is not defined on the right. But what I can say about this point, however, is that is the absolute min, because there is no other value smaller than it. I can also say about this point that it's an absolute max as well, because there is no other value. Notice that this function domain is between this -5 and 10, nothing beyond that. So this is not just a local max because I can show the open interval, but it's also the absolute max. This one at the endpoint of the interval will never be a local, but it is the absolute because there is no other value smaller than it. So local or relative cannot be at the endpoints of the interval. That's one thing. And the local has to, if it exists, the function has to exist on both sides. Now, I think we're ready to look at a problem in which we go through all these questions. A complete problem. We only did partial problems last time. So we have a lot of questions on this. I'm going to write them down, and then you can copy it afterwards if you'd like. Let me just do that. Okay, while we talk. Okay, so first question here is asking us to find the domain of this function. What do you think about the domain? So this is problem 50 on page 251. What do you think about the domain?
More than -1.
Domain.
-3.
Thank you very much. Yes. So part A, negative infinity to infinity is the domain of this function. Perfect. Is that clear? Any questions on the domain? Okay, what about the range? Yes, do we all agree with negative infinity to 4? Yes? Good, so then part B, the range, negative infinity to 4 with a bracket. The x-intercepts, please. Also called the zeros of the function, and please present them as an ordered pair. Yes, as an ordered pair, please. Careful. So x-intercepts or zeros. So they are negative 4 comma 0 and 4 comma 0. Very good. Do you all agree with negative 4 comma 0 and 4 comma 0 for the x-intercept or the zeros of the function? Yes? Perfect. Next question. The y-intercept, part D. What is the, yes, the y-intercept is 0 comma 1. Do we all agree with 0 comma 1 as the y-intercept? Perfect. Next. Intervals on which f is increasing. F is increasing on okay. We're talking about the trend. We don't care about which value to which value. We're only interested on the x-axis, and we say between these two values, the function is increasing. Between these two values, the function is decreasing. Not from which value till which value. So increasing, decreasing, and constant values are read on the x-axis. So please do not give me anything that has y in it.
So -4 and -1.
From negative infinity till negative 2, the function is increasing. Union. From 0 to 3, the function is increasing. Do we agree?
Yeah.
Okay, so negative infinity to negative 2, union 0 to 3. Is that clear? Yes? Do I need to show again? I will be more than happy to. Is this clear? Yes. So the function is increasing from this territory till this territory, the function is increasing. From this territory, from this point till this point, the function is decreasing. From this point till this point, the function is increasing. And from this x value to this x value, the function is decreasing. Is that better? Awesome. Since I have to use this again for other classes, I need to clean it up. Is that clear? Yes? Perfect. Okay, so we have increasing of negative infinity to negative 2 and 0 to 3. And now next question, decreasing on negative 2 to 0, union 3 to infinity. Very good. Excellent. The values of x for which f of x is greater than or less than or equal to 0. So let's talk about this for a moment. Let's look at this graph. I see portions of the graph under the x-axis, some portion of the graph above the x-axis, and then another portion below the x-axis, correct? So if we pick a number of x for x between negative 4 and 4, would you agree that the function value will be positive? Right? So for x equals 2, I get this value, which is positive. For x equals negative 2, I get this value, which is positive, and so on and so forth, correct? But what about 5? What about 10? What about negative 10? What kind of values will the function have for those values? Negative. So now we're asked to solve the inequality f of x less than or equal to 0. Y, or the function, less than or equal to 0. We need to pick the x values for that. Where will I find those x values? So we will write what? This is question G, yes. F of x less than or equal to 0 is where? For x in the interval? where will I pick x values to find f of x negative? Okay, let's analyze it again. It means that it's not clear. If I pick -5, what will the function value be? Good. If I pick -2, if I pick 10, which x values will give us negative y values? Between negative infinity till -4, union. Of course. Is that clear? So every time I pick to the right-hand side of 4 or to the left-hand side of -4, the answer will always be negative. Would you accept? Perfect. Next question. They're asking us to find the numbers at which f has a relative max. Does this function have a relative max? Yes. It has a relative max where? It has a relative max where? I didn't ask the value of the maximum. We have to make a distinction. It's a very good point. So when I'm asked where, it's the location. When I'm asked how much, it's the height. So we have, the function has a local max at -2, and it has like a local max at 3. And now the next question would ask us how much. At -2, the maximum is 4. At +3, the maximum is 2. That's it. So these are two separate questions. When I'm asked the location, I give x. When I'm asked how much, I give y. So that was h. So at x equals -2 and at x equals 3. Local max. And then question I, find the relative max. Find the relative max. So at x equals -2, the relative max, you told me it was 4, and at x equals 3, the relative max was 2. Okay, find that they're asking us to find f of -2. What if I ask you, if I want to add a question here, does this function have a minimum, a local minimum? Yes. Up to a maximum, down to a minimum, up to a maximum, down. So does this function have a local min? Yes. Correct. Where? Where? Location. Where? 0. How much? 1. That's it. Awesome. Okay, f of -2, please. The next question was J. F of -2. What is it? Okay, we already know that. Perfect. The values of x for which f of x is 0. K. F of x is 0. What does that mean? What am I asked to find now?
X-Intercepts.
Of course, or the zeros of the function. So they were asking this. They are asking the same question twice in two different ways, and we will write x equals -4 and x equals 4. Okay, it's just that in the first situation I will answer as an ordered pair. Here I will not, because I'm asked to solve the equation f of x. Okay, last question. L, is this function symmetric? Is it odd, even, or none of the above? None of the above. Because I cannot fold the paper and they will not overlap, right? So that's not going to happen. What I have here, I don't have here, and what I have here, I don't have here, because a function that is odd has to be, let's look at an example. Here it is. This is an odd function. Symmetric with respect to the origin. This, an odd function, symmetric with respect to the origin. This is an even function, symmetric with respect to the y-axis. Very good. Is it clear? Let me show you what I wrote down while we were talking. So this was problem 50 on page 251. Oh, no one can see anything. Sorry. So this is what I wrote. I wrote that the domain was -∞ to infinity. Then the range -∞ to 4. The x-intercepts or the zeros, -4, 0, 4, 0. The y-intercept 0, 1. Increasing on this, decreasing on that. f of x less than or equal to 0. You told me between negative infinity and negative 4, union 4 to infinity. Local max at negative 2 and 3, and respectively the relative max for this is 4 and the relative max for this is 2. We knew that f of negative 2 is 4, and the zeros again at negative 4 and 4. Do we understand this type of problem? Do you think we need another example, or we are in the clear with this? You decide. I'm sorry? Which part is not clear from the whole thing? Because it can be just everything. Maybe I can just focus on that situation that you have questions on. Okay, let's look at another. Let's say 52. I'm not going to write the answers now, so let's just go over the questions. So, question part A, what is the domain of this function? Notice the arrow, and notice the full point. Negative infinity to 6 with a bracket, correct? Do we all agree with the domain between negative infinity and 6? Okay, the range, please. Negative infinity up till? Now up till 1. Do you agree with that? Yes? Olu, is that okay? Okay, the zeros of this function, please. Do you agree with negative 3 and 3 as the zeros? Okay. F of 0, please. F of 0. 1. F of 0 is 1. It's also called what? The y-intercept. Awesome. Intervals on which f is increasing. Very good. Negative infinity to negative 2. Awesome. Decreasing. 2 to 6. Very good. 2 to 6. Awesome. Intervals of which the function is constant. Negative 2 to 2. Values of x for which f of x is strictly greater than 0. Above the x-axis. F of x strictly above the x-axis. Between negative 3 and 3. Strictly above the x-axis, correct? For any x value between negative 3 and 3. Values of x for which f of x is negative 2. Let me refresh your memory. You have to draw this. It crosses the function, and you have to identify the x value. Do you agree with negative 5 and 5? We all agree with negative 5 and 5. Okay. Is f of 4 positive or negative? Is f of 4 positive or negative? Yes. F of 4 is negative. It's just right here, negative 1. Awesome. Is this function even, odd, or none of the above?
Even.
Careful, it's a full point, and it's a arrow. Again, it's not symmetric. It's not a symmetric function. And is f of 2 a relative max? So f of 2 here. I disagree with this book. They say no. I disagree because the values can equal each other, but they don't consider that in this book. But so let's go with what they say. They say no, but it's correct. It also can be considered a relative max.
So if we say that on the test, you would want us know?
No, I would not. I would not put a problem like that with a constant and ask you if a corner is any point here is also a local max and a local min if it's a constant. But they don't want to differentiate in the algebra. But it's totally different in calculus. That's all the point I was making. Okay, very good. Any questions? Is this better? Yes? Okay, perfect. That's all I had to say about this section, and then let's look at the other two, 2.3 and 2.4, and that will be the end. I brought a packet for you, so please don't forget. I want to give it to you.
Is that like a test?
No, I just created a test in my math lab, and I printed it out. Just an example. but we're going to review on Wednesday anyway. But I would like you to work on this between now and Wednesday and see where we need to emphasize what, because in an hour and 15 minutes or 20 minutes, we're not going to be able to go through everything, right? So I just want you to decide what to do on Wednesday. So here we'll talk about lines. So let's look at a quick review, and we know that one thing that we will have to review, I would like to review with you, is graphing using X and Y-intercepts. Then I would like to go over the equation of the slope, which is y2 minus y1 over x2 minus x1 slope, rise over run. That's the steepness of the line. Nothing here is new. I'm just listing things that you already know. Then we have y equals mx plus b, where b is, anyone remembers? The m is the slope, but b is, right, but please remember, is 0, comma, a number. This is the y-intercept. You gave me a few minutes ago 0, comma 1 for a previous function. That was the y-intercept. If it doesn't have 0 for x, it's not the y-intercept. Okay, number 4. Y minus y1 equals the slope times x minus x1. This is the point slope form. So this is the slope y-intercept. Slope intercept form. And this is the point slope form. Five, we're going to talk about the average rate of change, which is nothing else. I'll explain to you in a moment, or maybe we should do it right now. So for a function, let's say this is a function. Let's suppose we want to determine the average rate of change between these 2 points, A and B. If this is x1, I would like someone to give us the y coordinate. I know I repeat myself a lot, but this is so important. Very good. And let's say, of course, this will, what do you think I'm going to denote this by? Of course. And please give me the y coordinate of this. Good. So the average rate of change is between these 2 points, A and B, between A and B. Normally is written better as x1 comma x2, to be exact. Will be. So this is the slope of this line. Can anyone give us the slope of this line? And that's the average rate of change. Say it again. F of
X plus H.
X to the second.
x2 minus?
F of X. Can't you say Y? Can't you say Y?
No, because it's a very good point you're making. Here, it's the average rate of change of a function. It's not just simply the slope of a line. It happens to be simply the slope of a line, but it's specific for a function. Over?
X2.
Right. Very good. Okay, then item number 6. Parallel lines. And last one, item number 7, perpendicular lines. Okay, so here's an example of 2 lines that are parallel, and here's an example of 2 lines that are perpendicular. They form 4 90-degree angles. What is the relationship between slope 1 and slope 2? What is the relationship between slope 1? Of course, the slope of the lines. What is the relationship between the 2 slopes in the first case? The slope of M. Perfect. Awesome. Indeed. M1 equals M2. What about when they are perpendicular? No. M1 is the negative multiplicative inverse of M2, not opposites. Yes, so now you can, if you like, I'll tell you how I remember it. Because you can cross multiply, right? We've discussed that. M1 times M2 equals -1. So which one is easier, to say that M1 is the negative multiplicative inverse of the other slope, or you can say the product is -1? I think so, but it's up to you. It doesn't matter, really, it's the same thing. So now let's practice all these. On page first into that 3. So let's look at, let's say, problem 4. And this is on page 267. We are given 2 points, -1, 3, and 2, 4. I pick those 2 points, or you can give me 2 points. It doesn't matter, really. But I'd like us to determine the equation of the line passing through them. So I'm ready when you are. What do I have to determine first? Awesome. So first I will denote this by x1, y1, or just think that I'm doing that. You don't have to literally write it. And then I will find the slope, and I will write the definition y2 minus y1 over x2 minus x1. So I get 4 minus 3 over 2 minus -1, which is indeed 1/3. Now, is any of these 2 the y-intercept? No. So then I will be using y minus y1 equals the slope times x minus x1, where the slope is 1/3. Now, you choose which point you want to use. It doesn't matter. It doesn't matter. We'll get the same answer. If I use the first point and put it here, and you use the second point and put it here, you're going to get the same equation. Just decide which point you would like to use. If you like to use the first one, then you put -1 and 3. And now we put everything together. Ready? So y minus 3 equals 1/3. Careful now, that's why I did this, so I don't have to write too many nested parentheses. X minus -1 will be x plus 1. Distribute 1/3 x plus 1/3, and you have to add 3. So remember, we know how to add fractions. We have to find the least common denominator, and I have to multiply this by 3. So 3 plus 1 will be 10. You know what I meant. 3 times 3 plus 1 will be 10. So y equals 1/3 x plus 10/3. This is the equation of the line passing through the given ordered pairs. Any questions? Any questions?
Can you just explain that?
Yes?
I know that
1 over 3 plus 3 over 1. The least common denominator is 3. 3 was not multiplied by anything. 1 was multiplied by 3. So 1 plus 3 times 3 is 10 over 3. Better? Other questions, please. Before, yes?
Why did we
Yes?
use this equation instead of putting it into the y equals mx plus
Because when I asked, are we given the y-intercept, everyone said no. So I can't use the first one.
I can solve for me. We couldn't have just solved for me.
Yes, you can. I accept that method. But it means this instead of this. It's up to you. I'm fine. I'm fine.
Okay.
So, but there is no need, really, for that. But yes, you can do it. It's acceptable. It's a perfect method. Why they do it in high school, I have no idea. Okay, so let's take a look at graphing using X and Y-intercepts now. So let's say 68 on 267, where 6x minus 9y minus 18 equals 0. we're asked to graph this function graph for the line, the equation, using X and Y-intercepts. Let's refresh our memory on one thing. What is the equation of this line? What is the equation of this line? Excellent. Altitude 0. Awesome. Remember, y is the altitude. Okay, what is the equation of this line? We're talking about position now. Awesome. That's exactly what we're going to use to determine the x and y intercepts. So one more time, 6x minus 9y minus 18 equals 0. I will make x equal 0 by simply covering it. It's 0. 6 times 0 is 0. So the equation I have to solve is negative 9y equals 18. How much will I get for y? Do you all agree with that? Can anyone give us the ordered pair? Excellent. Very good. So now I have to make y equals 0, and I'm going to cover this one. I'm going to move negative 18 to the other side, and I have 6x equals 18. So how much is x? Very good. Can anyone give us the ordered pair now? That's all I need. Please do not waste your time to solve for y. There is no need to solve for y and determine the slope. Please don't use the slope. The reason is there is no other function that you can use the slope for. So if there is no other function that you can use the slope for, why bother? We will always need the x and y intercepts. See you on Wednesday. Very good. So now let's graph. So the first order pair, it doesn't matter. The order is not important here. 0, negative 2 is this, and 3, 0 is this. Connect and extend. Please write 6x minus 9y minus 18 equals 0 anywhere you want near the graph. Above, below, left, right, whatever you want. Any questions so far?